Welcome everybody. In this video where we will be discussing a few problems based on the properties of determinants, and I've taken these problems from the Maharashtra government textbook 11th standard maths part 1. Now in case if you're not very clear with the properties of determinants or if you've forgotten them, then do check out the description box where I have left a link, and that link is to a video in which I have discussed the entire theory related to determinants in a lot of detail, and that video will really help you to get a firm grip on the properties and also the other theory which is related to determinants. So if you're clear with the properties, let's begin with the questions. So here's the first question. Without expanding the determinants, you need to evaluate them. So check the first determinant. Now in this determinant, if you check the last column of every term is having one term short of the ideal a plus b plus c expression. Now you have ABC here, and those are the terms missing in the last column. So what we can do is we can add the column 2 terms to column 3. For that the operation will be C3 undergoing C3 plus C2, and that would make the determinant look like this. So that's 1 1 1 A B C, and finally the last column will be a plus b plus c. Even this will be a plus b plus c, and this will also be a plus b plus c. From the third column you can pull out a plus b plus c common, and that a plus b plus c can be written outside the determinant right here, and you will be left with 1 1 1 as the elements in your last column. Now column 1 and column 3 are exactly identical, and because column 1 and column 3 are exactly identical, the value for this determinant will be 0. So we have 0 into ABC, that is equal to 0, and that 0 is the final value of the first determinant. Let's go ahead with the second determinant. Now in the second determinant, from the last column you can pull out a 3x common. So when you're pulling out a 3x common from the last, okay, in case if I have said column it's wrong, you're pulling out 3x common from the last row. So after pulling out a 3x common from the last row, this determinant will be 2 3 4 5 6 8, and the last column will now be 2 9x. So when you're pulling out a 3x common, that will become 3. From 12x, when you pull out a 3x common, this will become 4. Now first row and third row in this determinant are identical, and that is why the value for this determinant will be 0. So we have 3x into 0, which is equal to 0, and that 0 is the final value for the second determinant. In a similar way, let's try to evaluate the third determinant. So for the third determinant, what we can do is we need to actually cut down these numbers to a smaller value, and for breaking them down or just to reduce them to a smaller value, if you realize the nearest multiple of 7 will be 63, and 7 is basically 7 into 9 will give you 63. So from 65, if I want to subtract 63, I should go for C3. From C3 I will subtract 9 times C2. So on performing this operation, C1 and C2 remain the same, but C3 will now become something like this. 65 minus 9 times 7, that is 65 minus 63, that will be 2. 75 minus 9 times 8, that is 75 minus 72, that will be 3. 86 minus 9 times 9, that is 86 minus 81, that will be 5. Now after that transformation, column 1 and column 3 are becoming identical, and that is why the value for the third determinant will also be equal to 0. So this is how you are evaluating the third determinant without expanding it. Going ahead with question number 2, you need to prove that this determinant will be equal to this. Now the first very step is something that you might wonder, how will we come to know that this is what we have to do? So for that purpose, the only answer is practice as many questions as you can, and with a tremendous amount of practice, these are certain steps that you will be able to imagine by yourself. So in this determinant, if we want an x term here, what we can do is we can add up this along with this, and from that we will subtract this. So that will make the first term as 2x, and because it is making the first term as 2x, the other terms will be taken care of by themselves. So we are adding this and subtracting this, that is we are adding C1 and C3 and subtracting C2. So the operation to be performed is this. The change is in C1 and the change is C1 plus C3 minus C2. That will make our determinant look like this. So x plus y plus z plus x minus y plus z. So that will make it 2x here. This plus this minus this will make it 2z here, and this plus this minus this will make it 2y as the term here. And then we have y plus z, then we have x plus y, then we have z plus x, then we have z plus x here, then we have y plus z, and then we have x plus y. Okay, so we can pull out a 2 common from the first column. And now that we want the terms in the second column as y, x and z. We want y, x and z, but we have this extra z, y and x with us. That z, y and x can be eliminated. Okay, we can eliminate that z, y, x from here, but to do that we have this x, z and y as extra terms in the third column. So what we can do is we can go for C3 minus C1, and C3 minus C1 will eliminate this x, this z and this y. And after this has been done, then we can go for C2 minus C3, and C2 minus C3 will eliminate the z here, the y term here and the x term here. So finally this is what the determinant is going to look like. So with these steps, this determinant is getting transformed to this, that is this determinant. Okay, so this is how we are solving our second question. In a similar way, let's go ahead with the third one. Now in the third one, we need to prove that the value for this will be 4 times ABC. Okay, I think we can subtract from the first column, second and third column. Let's see what do we get. So C1, we are transforming it by going ahead with C1 minus C2 minus C3. So that will make our determinant look like this. The first term will be 0. This minus this will make it minus 2C. This minus this will again make it minus 2C. So here we have A plus C, C, B, C and B plus C. So from here when we are pulling out a minus 2C common, or okay, let's pull out a minus 2C common. So minus 2C comes here and we have a 1 and 1 here. Let's go for R2 minus R1. So R2 minus R1, 1 minus 1 will give me 0. A plus C minus C, that will give us A. C minus B plus C, that will give us minus B. Okay, let's go for R1 plus R2. So R1 plus R2 will give us 0 plus 0, which is 0 plus 0, which is 0. A plus A, that will be 2A. And B plus minus B, that will be 0. From the first row, you can pull out a 2A common. So this becomes 1 and we are multiplying this with 2A. So this term is becoming equal to minus 4AC. Let's see if we can do anything with these two terms now. Or let's go ahead with expanding this now. So if we expand the determinant here, anyway the first term will be 0 into something which is 0. The second term will be minus 1 into 0 minus of minus b, that is into 0 plus b. So that will be minus 1 into b, and the third term, that will be 0 into something which is equal to 0. So this is the value of our determinant, which was further multiplied with minus 4ac. Okay, so this becomes minus b, and minus b into minus 4ac makes it 4abc, and that is what the right hand side was. Yeah, so that is how we are proving, or that is how we are answering our first question. Moving ahead with the third one. Okay, every term is in log and these ones are troubling us to some extent. So what we can do is we can write these ones can be written as, we can write this one as log of x to the base x. This one can be written as log y to the base y, and this one can be written as log z to the base z. Now log x to the base x, we can write that as log x upon log x. Similarly, this term can be written as log x upon log y. So let's write it again, the entire determinant. The first term, log x upon log x. This term is log x upon log y. The last term is log x upon log z. Then comes the second column, the first term being log y upon log x, this term being log y upon log y, and this term being log y upon log z. Similarly, let's quickly write the third column, log z upon log x, then we have log z upon log y, and here we have log z upon log z. Okay, so what we can do is we can take from the numerator, from the first column, every numerator has a log x term with it. So from the numerator we can take log x common. That log x goes out. From the second column, the numerator of every term is log y. So we can take a log y common from the numerator of every term. So into log y. Then from the numerator of the third column we can take log z common. So into log z. Divided by, now from the first row there's a log x in the denominator of every term. So when that log x from the denominator of every term goes out common, this entire row becomes 1, 1, 1. We get a log x in the denominator here. Similarly, from the second row and the third row, we can take a log y and log z common from the denominators. So that will make our determinant 1, 1, 1. In the denominator, we will have log x, log y and log z. So log x in the numerator gets cancelled. Log y and log z also get cancelled. So outside you are left simply and simply with 1. Now whatever you have outside does not make much of a difference, because if you check this determinant, it's like C2 and C3 are identical, or you can say C1 and C2 are identical, or you can say R1 and R3 are identical, R1 and R3 are identical. In short, if any two rows or any two columns are identical, the determinant value will be 0. So this determinant value will be 0. So the answer is 0 into 1, which is equal to 0. Yeah, that's how we are answering the second part of our third question. Okay, so there's a typing error in the textbook itself. They haven't typed they have not given the question number 4 in the textbook. There's question number 3, and immediately after that there is question number 5. So I've kept the numbers in the video also in the same way, because if you are referring these questions from the textbook, then I wanted that you guys don't get confused with that. So yeah, that's what it is. There's no fourth question in the book, and that's why we are just continuing ahead with the fifth question. Okay, if there's an x term with every element of this determinant, what you can do to simplify the determinant is go for C1, C1 minus C2, and go for C2, C2 minus C3. It does not matter in whatever order you subtract the columns or the rows, it is entirely up to you. I have just selected C1 minus C2 and C2 minus C3. You can go for C2 minus C1 and C3 minus C1. The ultimate idea is subtract the rows or subtract the columns to eliminate as many x terms as possible. So after these operations, I am going for C1 minus C2, right? So C1 minus C2. That will give me this minus this, that is minus 4. This minus this, which will be 7. This minus this, that is minus 3. Then I am going for C2 minus C3. So this minus this, which is giving me a 7. This minus this, which is giving me minus 3. This minus this, which is giving me a minus 4 again. So here we have x minus 1. X plus 2 and x plus 6, which is equal to 0. Let's go for R2 minus R1. So 7 minus minus 4, that will give us 11. This minus this would give us minus 10. And this minus this will give us 3. Similarly, let's go for R3 minus R1. So this minus this will give us a minus 1 here. Sorry, will give us a plus 1 here. This minus this will give us minus 11. And this minus this will give us a 7. Yeah, I think evaluating this will be an easier task now. So if we expand this entire determinant, we have minus 4 into minus 70 plus 33. Minus 70 plus 33, that will be minus 37. Then we have minus 7. multiplied by 77 minus 33, 77 minus 3, 77 minus 3, that will be 74, and then we have plus x minus 1, the whole multiplied by minus 121 plus 10, that is minus 111, and this will be equal to 0. So we have a 37 coming common from this entire expression. So we have 37. This will be minus 4 into minus 1, that is 4. This was 37 into 2. So 7 into 2 will give us a minus 14. And from here, when I am taking out 37 common, this will be minus 3. Minus 3 into x minus 1, that will be minus 3x plus 3 equal to 0. 4 minus 14 will be minus 10. Minus 10 plus 3, that will be minus 7. So we have 37 into minus 7 minus 3x equal to 0. 37 goes on the right, we have minus 7 minus 3x equal to 0. 7 goes on the right, so we have minus 3x equal to 7. So x will be equal to minus of 7 upon 3. Yeah, that's how we are answering our first question. And let's go ahead with the second part of the fifth question. And to solve this, all you need to do is simply expand the determinant. So that will be x minus 1 into x minus 2 into x minus 3 minus 0. So that will simply be x minus 1 into x minus 2 into x minus 3 minus x into 0 plus x minus 2 into 0. So the last two terms are anyway 0. So we have the value for the determinant as only the first term, which is this, and that value has been given to us as 0. So from here we can say that x will either be equal to 1 or x will be 2 or x will be equal to 3. Let's go ahead with the sixth question. And again in this question we have to try to eliminate as many x terms as possible. That wouldn't be very easy like the previous question that we had done. It will be a little trickier than the last one, but definitely it's not a very difficult question also. So all you need to do is let's try adding this and this. That is, let's try going for, okay, or rather I would say C2 plus C1 and C3 plus C1. Okay, so with the transformation of C2 plus C1 and even C3 plus C1, the determinant will look like this. So we will have 4 plus x. The first column is unchanged. The second column will be this plus this. So that will be 8. This plus this, that will again be 8. And this plus this, that will be 8 minus 2x. This will be this plus this, that is 8. This plus this, which is 8 minus 2x. And this plus this, which is equal to 8 again. Okay. Let's go for, okay, now let's go ahead with rows. Let's go for this plus this. So that will give us 8 here, 16 here, and 16 minus 2x here. Let's go for this plus this. So that will give us 8 here, 16 here, and a 16 here. Okay, can we do anything else beyond this? And the value for this determinant is 0. Okay, okay, let's go for this minus this. So that will give us a 0 here. It will give us 2x here, and this minus this will give us a 0 here. So this is minus 2x. Let's take out a 2x common from here. So this will be 1 minus 1, and a 2x is coming out common from the second column. Okay, I think this is going to work. So let's go for even this minus this. So that will give us a 0 here. This minus this will give me a 2 here. And this minus this, that's going to give me minus 2x here. So let's pull out a 2 common from here as well. So this will be minus x, 1. And a 2 comes out common from here. Anything else that we can do? I think we should go ahead with the expansion now. So that should make our work easier. Okay, let's go ahead with the expansion. This term will be 4x. Then we have 4 plus x into 16 minus x. So 4 plus x into 16 minus x minus 0 into whatever we have will be 0 only. And then we have 8 into minus 8. So we have minus 64 as our last term equal to 0. So either this will be 0 or this bracket will be 0. So either x will be equal to 0, or if we try to simplify this bracket, this will be 4 plus x into 16 minus x. So that is 64 minus 4x plus 16x minus x square. Okay. And then 64 minus 64, that becomes equal to 0. And minus 4x plus 16x, that will be 12x. Okay, so we have 12x minus x square. You can pull out another x common and write it as 12 minus x. Okay, so I think I can combine this x with the x here. So we have 4x square into 12 minus x equal to 0. So either x square will be 0, that is x will be 0, or 12 minus x will be 0, that is x will be equal to 12. So these are the possible solutions for question number 6. Moving ahead with one last question in this video, we need to prove without expanding that the combination of these two determinants will give us this. Now if you realize in the required determinant, you have 212 as your second column, but 212 here is the second row. That 212 is going to remain unchanged. Is there a 212 anywhere here? No, there's no 212 there. We have a 176 and we have a 176 here, and then we have a 233, but here we have a 133. So okay, we can pull out a 2 common from here. If we are pulling out a 2 common from here, this will be 2. So this will become 3, 2 and 6. Okay, so we do have this 326 here. We have a 326 here. We have a 317 and 317 here. Okay, so what we can do is we will take this 2 again inside the determinant, but multiply it with the first column. 2 will get multiplied with the first column. Even 4 will get multiplied with the first column. So the determinants will look like 2, 12 and 6. This will be 317 and this will be 326 plus, when 4 goes inside the first column here, we have 8, 8 and 4, and then we have 3, 1, 7, 3, 2, 6. Now because these two columns in the two determinants are identical, we can club the two determinants into one single determinant, just that the elements of your first column are going to get added and these two columns are going to remain identical. So adding them will give us 317, 326, and here it will be 2 plus 8, which will be equal to 10. Then it will be 12 plus 8, which is equal to 20. And then it will be 6 plus 4, which is equal to 10. So that is what our resultant determinant is going to look like. And in that resultant determinant, from the first column, we can pull out a 10 common. So that will give us a 10 here, and 1 to 1 as our first column. Now we can interchange the rows and columns of this determinant with each other. So that determinant will look like 10 times. The first row can be written as 1 to 1. The second column will become the second row here. And the third column will become the third row here. So this entire determinant has been simplified stepwise to this, which got simplified to this. So ultimately the combination of these two determinants is giving us this determinant, which is exactly the same as this. And yeah, that's how we are solving our 7th question. So yes, this is where I am done with discussing whatever I wanted to discuss in this video. I have also made a further video in which I have discussed the solutions to the entire miscellaneous exercise of this chapter from the government textbook. Do check out that video, and yeah, I hope that the contents of this video have been somewhere helpful to you in your preparations. Thank you for watching.